All right, so today we have Futoshi Yagi, who will tell us about O7-plane, freezing, and BPS jumping. Take it away.
Thank you very much. So thank you very much for giving me a chance to talk in this Quiver meeting. So today I would like to talk about this freezing thing, which O7-plane freezing and BPS jumping. And I'm Futoshi Yagi from School of Mathematics, Jiaotong University. And this work is based on two works with collaboration with H.Hayashi, Kim, and Kim Lee, and also Kim, Xiaobin Li, Satoshi Nawata. So let me start from the introduction. So my work is, almost all my work is somehow related to brain construction of gauge theory. So let me start from the basic review about the brain construction. So if we would like to construct the supersymmetric gauge theory with H supersymmetry, we use Hanani-Witten type brain setup. So it's like if we would like to consider the p-dimensional SUN gauge theory, we consider NDP brains suspended between two NS5 brains. So this is a very famous brain construction for supersymmetric gauge theory with H SUSY. And if we would like to construct not SU, but SP or SO, we use orientifold plane. And there are, so if we would like to construct, and depending on which gauge theory we would like to construct, we use different orientifold plane. So if we would like to have an SO gauge theory, then we use O plus plane, OP plus 2 plus plane. And if we would like to have an SP gauge theory, we use O minus plane, OP plus 2 minus plane. And this orientifold plane, with this orientifold plane, we can construct various types of gauge theory, and not only changing the gauge theory, but also we can construct some other SU gauge theory with more non-trivial representation, not only fundamental representation, but also symmetric representation or antisymmetric representation. This SYM stands for symmetric, and AS stands for anti-symmetric. And if we use this O plus plane, then we can create a symmetric hypermultiplet in symmetric representation. And if we use O minus plane, then we can construct a hypermultiplet in antisymmetric representation. And so by using this orientifold plane, we can create various types of supersymmetric gauge theory. And the topic today is actually, I would like to discuss some non-trivial relation between O7 plus plane and O7 minus plane with 8D7 brains. Or more generally, we can generalize this relation to generic dimension, like OP plus plane, the relation between OP plus plane and OP minus plane plus 2 to the power of P minus 4 DP brains. So in some sense, and I'm calling this freezing in a way, which means that if we locate O7 plus and 8D7 brains at the same position, and suppose that D7 brain do not move, fix the location of this D7 brain by hand at the location of O7 minus, which I call freezing. And then it behaves similar to O7 plus plane. So although O7 plus and O7 minus is different orientifold plane, and it also corresponds to different gauge group, but if D7 are located at the same position as O7 minus, these two behave in a similar way. So this is the kind of idea which I would like to investigate, and by using some concrete computation. And so in some sense, I try to discuss some kind of equivalence between O7 plus and O7 minus plus 8D7, but I'm not claiming that O7 plus plane consists of, I do not claim that O7 plus plane consists of O7 minus plus 8D7, or we can decompose into O7 plus 8D7 plane. I'm not saying such a thing, but still, if we fix the location of this O7 plane, they behave in a similar effect. So this is the theme of this talk. And first, why I begin to say this is based on the observation of charge. So this is one of the most simple, probably the simplest observation of some kind of equivalence between left-hand side and right-hand side. So it means that if the left-hand side, O7 plus have +4 RR charge, and the O7 minus have -4 RR charge, and each brane 1 RR charge and plus times 8. So the RR charge at left and right is identical. So especially if these D7 are at the same place as O7 minus, from the viewpoint of RR charge, they look similar. Yeah. So this is the first observation. And of course, this observation, everybody knows that this, or it's just as it is, it's just the agreement of charge, and it's too much to say equivalence. But this agreement of charge gives more consequence at the level of various properties, various things which we can compute. And in order to investigate this relation at the level of symmetric gauge theory, for example, we can consider something like this. I said that the 5-dimensional SUN plus 1 symmetric tensor can be realized by using O7 plus plane like this. And I said that I would like to consider the relation between this O7 plus and O7 minus plus 8D7. So let's replace by O7 plus, O7 minus plus 8D7. And then this with this O7 minus and 8D7, it looks like a 5-dimensional SUN plus 1 antisymmetric tensor constructed from, originated from O7 minus plus 8 flavor originated from this 8D7 branes. So again, I'm not saying that these two theories are dual or equivalent, but what I would like to say that if we tune the location of this O7 plane, O7 branes, or in other words, the mass of the 8 flavors, then these two theory behaves in a similar way at IR. So this is what I would like to investigate. By the way, when I say 5-dimension, this picture is slightly not very rigorous in a sense that when NS5 and D5 meet, the next brane should be like 1,1 brane. So, but in this picture, I'm writing all the P,1 5 brane in a vertical way to make the things simpler.
Can you make
this is one of the any questions?
Yeah, maybe you will address this later, but can you make the same picture in lower dimension? So with D4 and
yes. Yeah,
maybe that's
actually it doesn't need, yes, that's right. So if we would like to, sorry, I do not discuss in this talk, but by using this generalization, it's immediate to generalize to other dimension. For example, 4D plus 1 symmetric is 4D SUN plus 1 antisymmetric plus 4 flavor.
Yeah.
And if it's 3D, then it's 2 flavor. So we can also do this. But in this talk, for concreteness, I talk mainly about this 5D. And
okay, yeah, thank you.
Yes, thank you for your question. So, and another related but different relation as a consequence of this freezing is to, let's start with SU plus 1 symmetric. And then this, but with 8 but with this time, we tune the location of color brane 8D5 at the position of O7 plus. And at this stage, and then, as previously, let's formally replace this O7 plus by O7 minus and 8D7. So, and then, so this step is, I'm calling unfreezing in a sense that it's, if we start from this and go to left, then it's like freezing. And the opposite is like, I'm calling unfreezing, but anyway. So if we replace O7 plus by O7 minus plus 8D7, we obtain SU plus 1 antisymmetric plus 8 flavor. But because this, exactly at the location of D O7 plus, we have D5. So we can go to Higgs phase. So we can remove this D5 brane suspended between D7 brane and its mirror image. And after removing this D5 brane, by using Hanani-Witten transition, we can move this D7 brane outside. And the resulting theory looks like SU with 1 antisymmetric. And in many cases, for example, like in many quantities, even if there are many properties, many quantities which is insensitive to the value of the Higgs web. So even if we do Higgsing, many quantities are invariant, like Nekrasov partition functions, Seiberg-Witten curve, and so on. So if we compare such thing, we expect some kind of equivalence between this SU plus one symmetric with SU with 1 antisymmetric at the level of when you compare various quantity. So this is another kind of equivalence between two different theories. This time we tune the location of D5, which is to tune the web of Coulomb moduli. So in summary, I would like to show some kind of equivalence between, again, I would like to emphasize that it's duality. It's not duality, but this equivalence is up to tuning some quantity by hand. But anyway, so in this sense, some kind of equivalence between SUN plus 1 symmetric and SUN plus 1 antisymmetric plus 8 flavor, where this mass of 8 flavor is tuned, or SUN plus 1 symmetric and SUN plus 8 plus 1 symmetric, where the Coulomb branch of corresponding to 8 color brane is tuned. They will show similar property, at least when you compare some concrete thing like prepotential or Seiberg-Witten curve or Nekrasov partition function. And if we use the same analogy, same discussion, we can compare SO gauge theory with SPN with 8 flavor, or SPN gauge theory and SO2n plus 8 gauge theory. So in this talk, I would like to compare these two different gauge theory with tuning. Right-hand side have more degrees of freedom and we need to tune. So up to this tuning, there is some kind of equivalence, which I call freezing, at the level of cubic prepotential, Seiberg-Witten curve, and Nekrasov partition function. So this is what I would like to explain in this talk. So any question?
In the slide before,
yeah,
if we like just put the bottom line and the top line, you could get something like SUN plus SUN is equivalent to SUN plus 8 with 8 flavors.
Yes, yes.
This also a statement you would make, or did I get
sorry?
much there? It looks like if I put the bottom line into the top and then get rid of the symmetrics, it's a statement like SUN is equivalent to SUN plus 8 flavors. Can you make sense of this as well, or?
You combine first and second line?
Yeah, exactly. And then I subtract the symmetrics. I mean, not that meaningful of a comment. I'm just asking.
Maybe you add
get rid
8
of
flavor
yeah.
also to here. Yeah. This is possible. And this is probably just becomes, so if you add 8 flavor to here, and we should also add 8 flavor here, and then this, maybe you say disagree with this, and then we can go here. So SUN plus 8 plus 1 symmetric plus 8 flavor is SUN plus 1 symmetric.
Okay.
And this is actually just Higgsing. So if we tune the position of mass and color brain, then we can do Higgsing. And even if we do Higgsing, the value of Nekrasov partition function and so on is invariant. So the equivalence between this plus 8 flavor and this is just a Higgs.
That's classical Higgsing. Yeah.
Yes, yes.
Okay, but if we get rid of the symmetric, then the statement doesn't make sense because then it's not a Higgsing anymore.
That's right. That's right. Yes.
Okay, I understand.
Yeah, thank you for your question. Yes. So let me first compare at the level of cubic prepotential. So cubic prepotential, what I'm saying is discussed by Seiberg or interrogator Morrison-Seiberg's paper. And this is low energy effective prepotential of 5-dimensional n equals 1 gauge theory at Coulomb phase. And in this 5D gauge theory, on 5 or R4,1, it's like without compactification, it is known that there is no the correction to the for example effective coupling is like one loop exact, and there is no higher loop correction. So we can write down the prepotential in an exact way, and it turned out to be this Coulomb prepotential at Coulomb phase is exactly given by this cubic prepotential. And the first red part is just a classical prepotential, and this blue part is a one loop correction. When it appears when we integrate out this massive matter at some fixed Coulomb phase, and when we do this integration now, this one loop exact term appears. So, and I would like to compare. So this is basically given by, what should I say? We can compute this prepotential once we fix the gauge group and matter content, then we can compute this kind of thing. And I would like to compare this thing for two different gauge theory, which I seem to be equivalent in some sense up to tuning. So for example, we can consider SUN plus 1 antisymmetric plus 8 flavor. The cubic prepotential is given by this. And then I would like to tune the location of 8 flavor in such a way that it is the same height as the position of O7 minus. And the interpretation of this mass is that this fundamental flavor, mass of the fundamental flavor is the distance between the center of mass of color brain and this D7 brain. And mass of antisymmetric tensor is the distance between the center of mass of color brain and its counterpart of mirror image, or in some sense, the double of distance between O7 minus and center of mass. So if we would like to tune the O7 minus, then if we would like to tune the location of the D7 at the location of O7 minus, what we need to do is to tune that all the mass of the flavor is a half of antisymmetric mass. And so what I did is just substitute this to the above equation. And then what I observe is that the obtained prepotential agrees with the prepotential of SUN with one symmetric, where we identify symmetric mass as antisymmetric mass. So at least this naive observation of some equivalence up to tuning, like O7 minus plus 8D7 and O7 plus, can be confirmed at least at the level of this cubic prepotential if we tune the mass by hand. And we can do the similar thing for SU plus one symmetric and SUN with one antisymmetric. This is another example which I explained. In this case, we should tune the value of Coulomb moduli A. So the one of the Coulomb moduli, the location of the, so the value of the Coulomb moduli is controlled by the location of color brane. So we put in such a way that the location of color brane labeled by A is the half of symmetric mass. And due to some convention, there is some minus sign. But anyway, if we substitute and tune the 8 AI out of n plus 8 AIs, then what we obtain is the SUN, and the prepotential looks like SUN, cubic prepotential of SUN plus one antisymmetric. So this is again
Futoshi,
yes.
What is the gauge symmetry on the world volume of the 7 branes?
In some I think it's the so if it's O7 plus D7, I think it's SP, right? And if D7 O7 and D7, so world volume of D7, I think the symmetry is SP, and if it becomes O7 minus, then it's S. So.
Yeah, but since you are dealing here with so we should interpret the gauge symmetry as the flavor symmetry.
Yes, yes.
And so
yeah, but yeah, so in this talk, somehow at this stage, I'm ignoring the D7 brane dynamics by hand. It means that if we consider the symmetry on D7, this equivalence doesn't exist from the beginning. The left-hand side, right-hand side, the world volume of D7 is of course different. So in order to discuss this, I ignore the dynamics on D7 by hand and concentrate on the world volume theory of D5, and which means...
Yeah, but that's just, it's irrelevant for the question. I mean, this is just a statement of charge. But the question is what kind of, so from the point of view of the 5-dimensional gauge theory, you're tuning masses, right?
Yes.
And so by tuning those masses, you are preserving a part of the flavor symmetry that was in the case of zero masses, right? And this is what I'm driving to, right? You started with a certain number of flavors, all of them are massless, and now you want to give them mass. And so there is a residual symmetry which is left, and that's the question. So the way of answering it is to figure out what's the gauge symmetry on the 7 branes.
Well, I think yeah, of course, if we just tune, for example, if we just tune the mass to be specific value, and if we still ask the flavor symmetry, even if we tune the mass, we usually do not say that the global symmetry disappears. We usually don't say like that, in a sense that.
No, you should think of it as a Higgs mechanism on the world of the 7 branes, that you are tuning the masses. So you're not completely breaking the flavor symmetry, but you are preserving a subgroup of the original one.
Yeah. So that's what I hope to say. Like, and originally there are like, in this case, I think we have, I'm not sure.
But doesn't it go from SO2N to SUN? or 8 in this case, SO16 to SU8? Just move the
naively at this level, we say like this side is SO2N and this side is SPN plus sorry, is it the opposite? This
the other way around.
This side is SPN. This side is SO2N plus 8. So I think this is the typical global symmetry. So if we, starting from this, we have a SPN plus SO2N plus 16, sorry, SO2N plus 16 global symmetry. And if we freeze 8 degrees of freedom, it reduces to SPN. I think I'm thinking such kind of thing. So, by the way, this is similar to this kind of statement. No, sorry, this kind of statement. So, if we concentrate on the 7-brane symmetry on the 7-brane, this kind of observation can be also made. So I think this is what's going on.
Okay.
Yeah, thank you for your question. Yes. Okay, so what I observe is that at the level of cubic prepotential, the cubic prepotential of left-hand side theory and right-hand side theory is identical up to this tuning of mass or tuning of color brane Coulomb moduli. And analogous discussion can be done also by comparing SO and SP, either by tuning mass or tuning Coulomb moduli. So this kind of equivalence is realized at the level of cubic prepotential. So, so this is one of that check. So any question? So next, I would like to go to Seiberg-Witten curve. So I also would like to discuss that this kind of thing can be also discussed at the level of Seiberg-Witten curve. And in order to discuss Seiberg-Witten curve, it would be useful to discuss the construction of Seiberg-Witten curve based on this Hanani-Witten type brane setup. So as I said, for example, in the simple case, like n equals to SUN, gauge theory, for example, created by D4 brane suspended between two NS5. Then if we uplift to M theory, then D4 and NS5 are both becomes M5. So instead of saying many M5 branes of this shape, we can regard this whole thing as one single M5 brane of this shape. And this shape turned out to be identified as a Seiberg-Witten curve. If we concentrate on this 4-5 direction, 6 direction, and M theory circle direction. And this is how we construct Seiberg-Witten curve based on the brane setup. And if we would like to consider 5-dimensional gauge theory on S1, we first start from the NS5D5 setup, which is actually the 5-brane web setup of type 2B. And we compactify on one of the direction. So this corresponds to the thing, like we are considering 5D gauge theory on S1. And then after T-dual, we end up with this NS5D4 setup, but only the difference is that one of the direction is compactified, but we can further uplift to M theory, and this M5 brane configuration is again Seiberg-Witten curve for 5D n equals 1 gauge theory on S1. And so so this is an explanation of PQ5 brane, but I think I can skip the detail of the PQ5 brane. And but anyway, so we can write down the PQ5 brane for example, for 5D n equals 1 SU2 supernaive theory. And based on this 5-brane web, we can take the dual graph. Dual graph means like an face correspond to vertex and the edge correspond to orthogonal edge and so on. And each vertex correspond to the monomial inside the Seiberg-Witten curve. And this is how we can practically construct Seiberg-Witten curve. And this idea can be generalized also with the existence of orientifold plane. So with the orientifold plane, we need to do two things. One is to impose the invariance under this Z2 symmetry, because the orientifold act on as Z, like a reflection or rotation to the space-time. So we impose the invariance under this Z2 symmetry. And on top of that, we impose some boundary condition at the, like a behavior at the position of, at the place of orientifold. And this is the effect of having, for example, O7 plus plane having the RL charge. And because of this, effectively there is a repulsive force, and the M5 brane is pushed to the infinity. And this correspond to the condition like W equals +1 or -1 when we go T goes to 0 or T goes to infinity. By the way, this W goes to 0 means W is the direction of vertical direction, and W equals +1 or -1 means the position of O7 plus. And T equals 0 or infinity is left or right. And because of this, by imposing these two boundary conditions, we can write down the structure of the Seiberg-Witten curve in this way. And we can do the similar thing for 5D-SPN. And actually, the Seiberg-Witten curve for 5D-SPN have some subtlety, and invariance is the same as before, but the boundary the condition, some constraint, further constraint due to this O7 minus plane was not considered correctly for 5D, and 5D SP gauge theory Seiberg-Witten curve is not written down very precisely until very recently, unlike SO case. SO case, it was known very long ago, but this paper by this by these people, but their paper also wrote down the 5D gauge Seiberg-Witten for 5D for SP, but this curve does not use the correct constraint due to the orientifold, and because of this, Seiberg-Witten curve from the current viewpoint for SP was not correct, and the correct one was not written down until very recently, until my collaborator and I wrote down explicitly. And this is and the boundary condition is that there should be a double root when you substitute equals to 1 or W equals to -1, which is a location of O7 minus. There should be we obtain the polynomial in T, and this have a double root. And this is, in other words, this phi brane go through this orientifold plane. This turned out to be the boundary condition. And because of this, we obtain this Seiberg-Witten curve. And based on this Seiberg-Witten curve, we tune the mass and then check the equivalence at the level of, also at the level of Seiberg-Witten curve. I said that 5D n equals 1 SPNs gauge theory with 8 flavor and 5D n equals 1 SO2n have equivalence if we tune the mass. And in this case, we tune the mass to be 4 of 0. It's like a massless. This is expected. But the other is we tune to be pi I. This pi I actually means that originally I wrote like an, so it's basically the value of m is the exponent of this part, and pi I means the value of this x4. And this x4 is the direction of T-dual direction. And somehow by taking the T-duality, I said that we take T-dual at this stage. And in this at this T-duality, O7 minus becomes 206, and 206 is located at the two diagonal place on the compactified circle. And this corresponds to the thing like 4 of the D4 brane. Now after T-dual, it becomes D4. 4 of the D4 brane is at the location of 106 plane, and the other 4 is located at the location of the other 06. So this is actually natural from the viewpoint of this brane setup. But compared to cubic prepotential, this has in some sense more information, in a sense that the cubic prepotential case, the tuning, we are looking only at the real part of this mass. Now, by compactifying on S1, this can also have an imaginary part, and we should also tune the imaginary part properly. And if we tune like this, then SP plus 8 flavor Seiberg-Witten curve becomes SO2N Seiberg-Witten curve. And we can do the similar thing also for symmetric plus flavor. So again, we impose similar boundary condition for SU with one symmetric plus flavor. And we can write down the Seiberg-Witten curve again in an explicit way by imposing this boundary condition in addition to the rule that from 5-brane web, we can write down the dual graph, and based on dual graph, we write down the Seiberg-Witten curve. And then in addition to that, we impose this bound condition, and we can obtain the Seiberg-Witten curve for symmetric. And antisymmetric case, okay.
I have a question about this curve, or this one or the previous one. So you write an equation,
yes,
right, which is invariant under W goes to W inverse.
Yes.
So the curve is actually then the quotient of the curve with that equation by this action, or is it the curve itself?
I think it's a quotient in a sense that
quotient, then it's just the curve associated to the web that you drew without the identifold, right?
Yeah.
So you have to take
this curve also includes mirror image. It's an analog of this kind of thing. For example, if you look at this, I think usually we say like upper half is a fundamental region, and the other half is like a mirror image obtained by this pi rotation. And Seiberg-Witten curve is writing the full configuration, also including mirror image. So,
right. So then after that, you have to take a quotient.
Yeah, I think the quotient is a real configuration of the M5 brane. But yeah, I think so. Yeah.
Okay. Thank you. Yeah.
So again, it becomes more complicated for SU with one antisymmetric, but we can also write down explicitly. By the way, this P2 or P3 is just a name of the polynomial in W, or Lowland polynomial in W. And we can write down, and the structure of the Seiberg-Witten curve can be written down this way. And again, we tune the mass in a similar way, but the real part is identical to the tuning which I introduced at the place of cubic prepotential. But again, we have this pi I shift for the 4D brane. And if we tune like this, Seiberg-Witten curve for SU plus 1 antisymmetric plus 8 flavor reduces to the Seiberg-Witten curve of SU plus 1 symmetric. So this is another the observation of freezing also at the level of Seiberg-Witten curve. So this is a summary. So what I explained is that, like, if we tune the mass, then we reproduce the Seiberg-Witten curve of the corresponding gauge theory. And in principle, I expect that the other one, like tuning A, should be also be able to done, but Seiberg-Witten curve is written in terms of the gauge invariant Coulomb moduli U instead of A. And in order to relate, we need to do A-cycle integral. And when we do this A-cycle integral, there is some subtlety, like somehow some special tuning of Coulomb moduli is a place where this A-cycle vanishes. So it's difficult to discuss the value of the A-cycle integral, and I didn't write in the paper. But anyway, so at least we expect the similar thing also for tuning the Coulomb moduli case. But I didn't explain in detail. So finally, I would like to discuss this freezing effect at the level of Nekrasov partition function. But before that, do you have any question? Okay, so let's also discuss at the level of this freezing at the level of Nekrasov partition function. So Nekrasov partition function, Nekrasov instanton partition function, which is defined for the 5D SUSY gauge theory on R4 cross S1, is given by the index of supersymmetric or ADH quantum mechanics, because this basically this ADHM quantum mechanics is a path integral over moduli space, or supersymmetric version of the instanton moduli space. If it's a 4D gauge theory, instanton moduli is just an what should I say? A finite dimensional space. Instanton moduli is a finite dimensional space. But if we have this S1, this moduli can depend on the time. And then this moduli looks like the one-dimensional field. So it becomes quantum mechanics. This is so anyway, so this is given by the integration over the instanton moduli space. And this is expressed as an index for supersymmetric quantum mechanics. And this can be understood as a generalization of Witten index. Like if it's only -1 to the F, it's a well-known Witten index, but we added various fugacities, which can be identified as a mass or Coulomb moduli and so on. And at the level of, in the language of 5D gauge theory. And also, unlike usual gauge theory, we also need to introduce this epsilon1, epsilon2, which is a fugacity related to space rotation. J1, J2 is a space-time rotation, and together with the SU2R rotation. This is like on top of so we also introduce epsilon2 when we compute the instanton partition function. And then, although this story is there is a very long story, but explicit formula is already how to compute is already studied in past papers, probably for non-trivial gauge group or non-trivial representation, starting from like Nekrasov and Shelchin, and there are various people. Actually, I'm not listing all the paper, but but by some other follow-up papers. Nowadays, we know how to compute Nekrasov partition function for SU with symmetric or SU with antisymmetric, and also for SP or SO, although I'm not writing. And how we compute is basically to multiply the corresponding matter content in the integrand. For example, SUN gauge theory always have a vector multiplet, so we multiply the contribution from vector multiplet. And in addition, for example, if we have a one symmetric tensor representation, we multiply the contribution from symmetric representation, and we multiply or have one antisymmetric and eight flavor, we multiply the contribution from antisymmetric given by, sorry, what I wrote anti is a AS, antisymmetric. And this flavor is this NF is the, again, it's DF, and this is the AS. Sorry, maybe I should. This is AS. This is F. Yeah, anyway, so we prepare the integrand corresponding to the each matter content, and each content include some variable which for example k variable for k instanton, and then we integrate and then this integration is actually something called JK residue, Jeffrey-Cohen residue, which is to pick up the pole created by this denominator by certain rule. So basically, and this rule is basically fixed. Once we know the integrand, we can tell which pole we should pick up and so on. And then we can compute this Nekrasov partition function. This is how we compute. And then by using this, and so, as I said, because which pole we should pick up is determined by the integrand. So if integrand agrees, it's already the agreement of the Nekrasov partition function. So practically what I did is to compare this integrand, which I call z curly z, compare the integrand by tuning mass or by tuning Coulomb moduli and check the agreement. For example, the integrand for symmetric and the integrand of antisymmetric and flavor agrees when you tune the mass, actually the mass of this SU with a flavor mass, to be tuned in this way. So what I draw this means this kind of combination. So again, this have more information than compared to the Seiberg-Witten curve. But if you turn off this epsilon plus or epsilon minus, by the way, epsilon plus or epsilon minus is some plus or minus of this epsilon 1, epsilon 2. This is the omega deformation parameter. And if we turn off this epsilon, the tuning agrees with what I explained at the place of Seiberg-Witten curve. But the Nekrasov partition function have this omega deformation parameter. And in order to obtain this agreement, we need to tune the mass depending on this omega deformation parameter. And this dependence on omega deformation parameter is not that obvious from intuitive brain construction. Rather, I found by kind of trial and error or observing left-hand side and right-hand side, and found, and we expect that we might have some correction depending on omega deformation parameter. And then by some trial and error, we found that by tuning mass in this way, we can see this agreement. And this immediately indicates that the Nekrasov partition function of SU with one symmetric and SU with one antisymmetric plus 8 flavor agrees if we tune the mass in this way. So at this stage, the identity of, I think it's already non-trivial, although the philosophy is very simple, like we replace O7 plus by O7 minus plus 8D7. And I said that this D7 is at the location of O7 minus, but this same position is actually slightly resolved by the parameter epsilon. And this is some non-trivial observation at the level of Nekrasov partition function. And we can also do the same thing for the comparison between SO2N and SP plus 8 flavor. And at this stage, another non-trivial thing is that the k instanton of SO2n correspond to 2k instanton in SP gauge theory with this tuning. And we also observe that the odd instanton for SP with 8 flavor simply vanishes if we tune the mass in this way. So therefore, the full part, the all-order partial function, like a full Nekrasov partial function, also agrees. But the correspondence is non-trivial, like k instanton and 2k instanton correspond between SO and SP. This is the observation. And next, I also would like to compare the SUN and SUN plus 1 antisymmetric with SUN plus 8 plus 1 symmetric. This is also another correspondence which I claimed, but this time somehow I don't know how to interpret, but I expected this kind of equivalence at the level of integrand, like because I believed that SUN plus 1 antisymmetric and SUN plus 1 symmetric is kind of equivalent if we tune the 8 D8 branes. But at the refined Nekrasov partial function, I couldn't find this kind of identity. But instead, what I found is somehow some kind of generalization of this kind of identity, which is to further increase the number of color brane and also increase the number of flavor. And we tune the color brane and flavor, the kilomoduli, 16 kilomoduli and 8 masses at the same time. And then we could find some equivalence. So honestly, I'm not very happy about this mysterious adding of further extra 8 flavor and 8 color brane. But what I could do at the level of refined Nekrasov partial function is to do this. But anyway, independent of apart from the interpretation, it is at least computationally true that if we tune the kilomoduli and mass to be like this, then the left-hand side and right-hand side agrees. So this is at least the correct observation. And another observation is that although I couldn't find expected property for generic epsilon 1 and epsilon 2, but if we consider unrefined limit, which is to take the limit of epsilon plus goes to 0, then we find the expected relation between SUN plus 1 antisymmetric and SUN plus 8 plus 1 symmetric by tuning the kilomoduli like this way. And again, if we further turn off this H bar, this H bar is the epsilon 1 equals minus epsilon 2 equals H bar. If we turn off this H bar, then this tuning is constant with, and also ignore this imaginary part, and then if we turn off this H bar, then this tuning is consistent with the cubic prepotential. So, but the subtlety is that these two, this factor actually include the epsilon plus to the power of k. And if we just substitute epsilon plus equals 0, then both sides vanishes. In order to avoid this, we remove such overall plus to the k factor and then compare, and we see the agreement. And this indicates that at the level of unrefined Nekrasov partial function, this also agrees with this expected tuning. So next, I also would like to discuss the because of this, but although this I said that the agreement of an integrand means the agreement of partial function, but there are some subtlety about this, something non-trivial about this equivalence. So I would like to explain this more in detail. And actually, these people, this Satoshi Nawata is my collaborator, and his students wrote down the Nekrasov partial function for SU with one symmetric in a very more explicitly by integrating out the or like picking up the performing the JK residue explicitly. They wrote down the formula depending on the Young diagram. So this shape is very natural generalization of ordinary SUN or UN Nekrasov partial function, and the partial function can be written as a sum of Young diagram, although the expression is more complicated. And then the very amazing thing is that, as I said, if we consider the SU plus one symmetric, as I said, for at least for generic Coulomb moduli, it can be written in as a Young diagram sum in this way. This is already written in Satoshi's paper. But at the same time, it is also written that the SUN with one antisymmetric Nekrasov partial function can be also written as a Young diagram sum. But this is written as a Young diagram sum with same ingredient, but multiplied by non-trivial constant. And this looks puzzling, but what we noticed is that although this SUN plus one symmetric is given by this formula of generic A, but if we tune the value of A, then the result is not given in this way anymore, but we need this constant. So depending on the position of the Coulomb moduli, like if we tune the Coulomb moduli at this smaller subspace, the expression for Nekrasov partial function changes. In other words, the value jumps at this region. And that's what I'm calling BPS jumping. And if in order to explain why it happens at the level of computation, real computation is very complicated, and somehow I give up, explain the very detail, but instead I prepared some toy model example, which is mathematically basically the same kind of thing, but easier to understand why it can happen. So JK residue is basically, when we compute the JK residue practically for multivariable, we first, for example, in this case, we have an residue at some pole at Z1 equals to 0 and Z2 equals to 0. And imagine that we take first residue at Z1 equals to 0 first, assuming that Z2 is not yet 0. And then after, it means that this if C is non-zero, then the pole comes only from this Z1. So we ignore this Z1 and substitute Z1 equals to 0. Then what we obtain is something like the remaining part. So we obtain something depending on Z2, and further take Z2 equals to 0 residue, we obtain 1 if C is non-zero. But if C is 0, then also from this part, already this part was nothing to do with pole structure, but only if C equals to 0. This Z1 plus Z2 also vanishes at Z1 equals to 0 and Z2 equals to 0, and the structure changes. And because of the change of this structure, the computation of the residue actually changes. If C is 0, and if you compute the residue in this order, you will find that the result is -1. So this is a mathematical kind of computational essence of the why, by changing the parameter, the result of the integral can suddenly jump. So this is actually happening in the computation of Nekrasov partition function when we compute the residue. So this is the that's why this kind of non-trivial jump can happen when you compute the partition function explicitly. And if you tune the parameter, this kind of jump can happen. So this was somehow amazing. Like, when originally I was studying this relation between SU with symmetric and SU with antisymmetric, but as a side byproduct, I also found that the Nekrasov partition function for SUN plus 1, 8 plus 1 symmetric Nekrasov partition function, for generic A, it's already known, but at some special value of A, the value jumps. This is, and this happens exactly at a place where this SU with symmetric agree with SU with one antisymmetric. So I think this is very non-trivial operation. So let me conclude. So we found the effect of this freezing, the relation between O7 plus and O7 minus plus 8D7 at the level of cubic prepotential, Seiberg-Witten curve, and Nekrasov partition function. If we tune the mass, or if we tune the value of Coulomb moduli, this equivalence predict some non-trivial identity between Nekrasov partition function or Seiberg-Witten curve and so on. And in this process, I also found the BPS jumping phenomena, which is like at the special value of Coulomb moduli, the Nekrasov partition function jumps. So thank you very much.
All right, let's thank Futoshi. Do we have questions?
I do have a question, yes.
Yes,
So about this BPS jumping, do you have any understanding of how this comes about at the level of central charges / wall crossing type of argument?
Central charge. Sorry, central charge means are you what?
I'm thinking of the walls of marginal stability and wall crossing phenomena in BPS spectrum.
First of all, this is slightly different from at least I would like to emphasize that this jump is different from wall crossing, because wall crossing is basically even if we jump from here to there, the two regions are same dimension, right? Like, and say there is a wall, and and then we this region to other region, there is some jump. But this one is slightly different in a sense that if we tune, like, it's more like a one point. If we concentrate on this 8-dimensional space parameterized by this 8 A's, it's just one point out of all the things. So when it comes to only this point, then some BPS spectrum changes. And so sorry. Anyway, as for question, I didn't think about central charge. So the answer is I don't know. But, at least I would like to emphasize that this phenomena is different from well-known crossing.
Yeah. Okay, thank you very much.
Yeah, thank you for your question.
Do we have more questions?
Futoshi, did you look what happens to the magnetic quivers between the two?
No. That's a really interesting question, but I didn't do that. Yeah, that should be another direction. So
it's not going to be a problem, right? Do you see any issue in computation?
I think although I didn't do systematically, but when at least I considered some magnetic quiver with the existence of orientifold, there is some other work. And in this process, I very powerfully observe that the rule for O-plane is similar to the rule. So like what I'm saying that this freezing phenomena, this the rule of this magnet. So we basically impose a rule of constructing magnetic quiver from phi, and then the rule under the existence of O7 plus and the rule under the existence of this was identical, at least for some example. So I don't know how much it means that this relation seems to be consistent also at the level of magnetic quiver. At least, by the way, I didn't emphasize anything in that paper, but I vaguely noticed that, oh, it looks similar. Okay.
Basically,
so I think, sorry?
What was the last statement? Basically, that what?
What did I say? Basically, it's similar. I didn't say much into
Okay.
So this works also. So in my impression, this works also at the level of magnetic quiver, although I didn't study systematically.
But I mean, I guess we don't expect that the different theories that are related by this equivalence in 5D, say the 5D SCFTs, which are on the next slide, for instance, we don't expect that they have the same magnetic quivers. Or for instance, those two.
Well, but
because there is some kind of Higgsing in between, so it's kind of a half Higgs.
But I think it's expected to be magnetic quiver can be the same because when we consider magnetic quiver, we go to like Higgs phase, so we need to tune the location of mass in any case, right?
So
and then
we are already...
and also what we observe is the phi brane. So even if we have an O-plane, O7 brane, and so on, magnetic quiver can be read off by the decomposition of phi brane part. And so if phi brane behaves in a similar way under the existence of O-plane, then the magnetic quiver can be the same. So I think we have hope that magnetic quiver is the same.
But then by what Julius was saying before, like this equivalence, like you can really have, then you would say that the theory of rank n and one other of rank n plus 8 with some slightly different matter, they would have the same magnetic quiver. This, well, maybe we could check it.
Maybe
but I don't think this will hold.
That's a good point.
I think there is it should be considered as some...
Okay. I think anyway, I'm optimistic about the first one. And I think the second one is the upper one, we tune the location of 7 brane and then look at the remaining 5 brane. But if the lower one, we need to tune the color brane. But if we ask the magnetic quiver, we read off the phi brane. We read off the magnetic quiver from phi brane. So even if we tune the phi brane, it still exists and it contributes to the matter content of the magnetic quiver. So unless we do some very artificial process to ignore the degree of freedom of this 8 quiver contributed in the magnetic theory, unless we do that, magnetic quiver will not agree in the lower case. But upper case, I think it's more optimistic. So we can say something about magnetic quiver also in this case, but yeah.
Okay. Thank you.
Yeah, thank you.
Do we have more questions? All right. If not, I would say let's thank Futoshi again.
Thank you very much.
You can go off the record.